Hello, everyone. This is Glenn Gray, Senior Solutions Architect with AppViewX. I appreciate you joining. We are going to begin in just a few moments. I'll start with an introduction, but I'm just going to wait about 30 seconds for additional attendees as they begin to arrive. So I appreciate your patience and bear with us just 30 more seconds. Thank you. Okay, so let's go ahead and get started. Once again, my name is Glenn Gray. I am a Senior Solutions Architect with AppViewX, as I mentioned, and joining me today is our primary presenter, Puneet Singh with Encryption Consulting, LLC. We are going to be discussing top 5 PKI Health Check issues. So with that, if we could go to the next slide, Puneet, we can just begin to cover let me pass it over to you so that we can get a voice print and you can introduce yourself.
Sure. Thank you, Glenn. My name is Puneet Singh, and as Glenn described just now, that I run the Encryption Consulting LLC, and we normally focus in the space of the PKI HSM's code signing, encryption, data masking, and tokenization. Glenn, I would pass it over back to you if you want to give an introduction regarding the AppViewX.
Sure. Thank you, Puneet. So AppViewX provides certificate lifecycle management services. So the AppViewX software platform helps to facilitate the overall lifecycle management of your PKI infrastructure and your certificate instances. A little bit of background on AppViewX. We provide low-code automation platform for workflow design. This enables NetOps, SecOps team to support business demands and greater agility. The AppViewX platform houses 2 products, the Cert Plus, which is the certificate lifecycle automation and management feature set, as well as Automation Plus that provides things like application delivery automation and network security automation. AppViewX has it has a number of Fortune 500 companies and performs at scale. And we are headquartered in New York City with additional offices in the US, UK, and India. And we employ over 300 people, and we've been around since, let's see, I think it's going on 10 years now. So back to you, Puneet.
Thank you, Glenn. Let me give you guys a little bit background about the encryption consulting. We are a startup and we have been in business for almost 2+ years now. And we have got roughly 30+ customers in the Fortune 500 for whom we provide the consulting in the space of the PKI, HSM, certificate management, code signing, encryption, tokenization, and data masking. And we are based out of the Dallas, Texas. Right now, it's a kind of a small practice, and we are growing. That being said, in the next 30 minutes, we will be discussing more about what are the top 5 PKI health check issues, what we have seen in the field. This is not an exhaustive list because there are a lot of other things which comes into the health check issues, but I have walked through that list and kind of put it together. What will be the top 5 things which people see while looking at going through the PKI assessment or going for the health check. If you guys want to get more exhaustive list, please feel free to reach to me after this webinar, and I will be more than happy to share that exhaustive list. So the first main issue what I have seen is that the root CA being offline. When different organization, if you talk to them, they will say that their root CA is offline, but it's not truly offline. When you're thinking of putting the root CA offline, which is acting as a trust of anchor, the best way to do is that either you put your root CA on a physical hardware or a laptop, but nowadays that's not possible. So people do go with the virtual machine, but they protect their private key of the root CA using the HSMs, where they can put a M of N kind of a control, so that it's not that just one person can fire up the root CA. And I would say the more tighter control you can have with respect to your root CA, the more better the security posture would be there for your overall PKI. There are 2-3 things I would like to bring to notice, is that you need to define a proper separation of roles and the separation of duties with respect to the root CA. You need to have a proper logging mechanism, so that if somebody is filing up the root CA, what activities they did, are they publishing the CRL, what are they doing actually, those all things have to be in place. And as much as you can put it offline, that would be kind of a best way to do the things. Again, just to summarize, it's better to have your root CA, the trust of anchor for your PKI, to be truly offline than just being offline or basically having a minimal control over it. The second issue, what I have seen in the field, is that people who have rolled out the PKI, they are either the enterprise Windows administrator or the domain controller people, and they don't know how actually the PKI has to be rolled out or how to secure the overall PKI in the environment, and they just go with the next and just put something in the environment so that people can get the certificates. I would bring to everyone notice that there are 3-4 important components which are there involved in the PKI, such as root CA, issuing CA, OCSP server, and NDES. It's always better to protect their private keys using the FIPS 140/2 level 3 compliant HSM devices, so that your PKI is not prone to the logical and the physical attack. If anybody is just installing the PKI and is not using the HSMs, the Microsoft PKI by default uses the DAPI APIs, and it's pretty easy to break it. If you will just do a little bit of Google search, you can find different utilities which are there available over the internet, which can help you take away the private keys of the root CA and the issuing CA without doing much of an effort, because it's just a registry setting in the Windows and it's really easy to get hold of the keys. So just to summarize, again, the second major issue, always use the hardware security module to protect the high value keys of root CA, issuing CA, network device enrollment service component, as well as the online certificate status protocol OCSP server private keys using the HSMs. Because when you use the HSM, those keys kind of becomes non-exportable and there is no way to take a dump of them or can walk away with those keys. So that being said, I'll move to the third top health check issue what I have seen in the market. That is with respect to the certificate revocation list management. And there are different things what I have seen in this, like as the problem areas with respect to the certificate revocation list. One, the top thing what I have seen is that when people design their certificate revocation list or the CDB points, they don't go through the proper inventory. What are the different type of operating systems present within their environment? Whether they're 60% of the organization is Windows or 40% consists of the Linux or the Macintosh. If they have gone through that inventory, I would always recommend to them that go with the STTP as the first point of the CDP or the CRL publication, and then go for the other CDP points such as Active Directory or the file share. The main reason why I bring this point is that now if you think that your organization is having 100% of the Linux or the Macintosh systems, then if you are using Active Directory as your first CDP points, CRL distribution point, then those machines are not part of the Active Directory and they cannot download the CRL directly from the Active Directory. and you are indirectly introducing a performance bottleneck into the system. So it's always better to go the HTTP as the first option. Second thing I would say is that as the common mistake what people do while working with the certificate revocation list is that by default the Delta CRL gets enabled in the Microsoft PKI and they don't disable it. And ideally what I have seen is that 90% of the organizations don't need the Delta CRL. Normally you need the Delta CRL only if your base CRL size is really big. And most of the organizations, if you talk about, it's in few KBs or MBs. It's not kind of a GB or like a 500 MB. So you don't need the Delta CRL. So I would highly recommend to disable it. And second thing with the Delta CRL is that if you will go and look into the file, it has a plus sign at the end, and the IS servers and other things kind of treat it as a vulnerability and won't kind of work with that. Now, another thing which with respect to the certification revocation list, people have to keep in mind is that how often they need to publish it. Because if you think that from the root CA perspective, normally you can either publish the CRL once in a quarter, once in 6 months, or once in a year. There is no kind of a best practice or a dictation that how often you should publish it. It all depends that what works for your organization. You don't want to have a kind of an operational overhead for your PKI team, but you still want to maintain the security of overall system. So you need to work it out that what will be the best way, what's going to work for my organization for publishing the CRL for the root CA. Similarly, you have to look for the CRL for the issuing CA. I would recommend that publishing the CRL for the issuing CA as often as possible, maybe 15 days or 7 days, because that will kind of give the up-to-date information to the end clients that what were the certificates which have been revoked. And that's where the solutions like AppViewX comes into picture, that they help you automate this whole thing with respect to the certification revocation list, as this is kind of one of the most critical part of the infrastructure, and you need to really have a high availability with respect to the certification revocation list. So just to summarize, whenever you're thinking with respect to your certificate revocation list management, try to keep in mind the how often the intervals of publication you have to keep in mind, then what should be the sequence of the CRL distribution points that you have to keep in mind. Then do you really need the Delta CRL? You need to ask that question and check. If you don't need it, then please disable that. Next thing I would like to bring to notice is that the misuse of the OCSP online certificate status protocol servers. Most of the people who are working with the Microsoft PKI, they think since it's a new thing, it's a cool thing, I should just implement it. But originally the OCSP server was designed to reduce the overall big sizes of the CRL to be transported to the endpoints of the CDPs. And it's also, as per the RFC, supposed to convey the real-time information whether the certificate is valid or not. And if you look at the way the Microsoft has implemented it, it's not actually achieving the goals for which this protocol was designed. So if you don't need the OCSP, you don't have to implement within your organization. You can still survive with your CDP points. Now, where the Microsoft works is that the Microsoft OCSP server kind of fetches the CRL still from the CDP points. It's not that root CA or the issuing CA is directly publishing the CRL at the OCSP point. And normally the end client kind of caches the response from the OCSP server, and it's not that for each and every request is going to the OCSP server. So again, just to summarize, if you don't have a really huge base CRL of like a 500 MB or something like that, then you don't need the OCSP server. If you really want to get the real-time information, that at every point I need the real-time information, then in spite of using the Microsoft OCSP server, I would recommend that go ahead and look at the other commercial OCSP server providers which are out there, because the way Microsoft has designed the OCSP is not the perfect way where you are not getting the real-time information. The last topic or the health check issue what I have seen is that people don't when they are implementing the PKI, they don't do a proper due diligence, and then they don't have the proper lifetime of their root CA, issuing CA, and entity certificate. What I normally recommend to my customer is that normally you have to work backwards from look at the lifetime of your entity certificate and normally try to multiply it by 2 and then come up with a life of a issuing CA, and then you multiply the life of the issuing CA by 2 and then you get the root CA lifetime. For example, if you are having a root, if you are having an entity certificate of 2 years, then if you multiply it by 2, it's a 4, but I normally go with the 5 years of the issuing CA because that will give you a bandwidth for renewing your issuing CA as well. And then if you multiply that 5 years of the issuing CA by 2, you get a 10 years of the lifetime of the root CA. And these decisions have to be made beforehand. So another thing is that look at the while you're deciding the lifetime of the entity certificate at the template level, look at the CA CAP forum recommendations and other things, so that you have the clear picture that what should be the lifetime. As of right now, I think the CA CAP forum mentioned that you need to have a 27 months lifetime of the SSL certificate, but I still recommend having a 1-year lifetime of our entity certificate should be more than sufficient. And if you have to rotate those certificates, there are solutions such as AppViewX which can help you guys with you that. That being said, there are other elements as well which you have to think, which I have not mentioned in this list, is that looking at the your trust model, that whether you need the 2-tier PKI, 3-tier PKI, or 1-tier PKI, that have to be, again, due diligence has to be done. And there are other factors which are there with respect to the PKI health check issues. And if you guys need the exhaustive list, please feel free to reach out to me. We at the Encryption Consulting provide services with respect to the PKI health check / assessments. And we do also have the PKI training, as well as we help design and implement PKI for our customers. So you can reach out to us for any of your PKI needs. Glenn, I will hand over to you. Do you want to add something?
Yeah, thank you, Puneet. Those were great concerns that you've pointed out, those top 5 considerations. And just to describe the relationship between Encryption Consulting and AppViewX, Encryption Consulting brings their expertise in PKI administration, and AppViewX provides, as a software platform, the ability to manage and automate the overall certificate lifecycle. Some of the items that you pointed out, I think, are especially critical when it comes to effective PKI administration and certificate administration. One of those being the ability to look at your chain of trust. You have a root, you have many times an intermediate, and then you have your issuing server instances, and how do you manage the generation of the certificate signing request, handing it over to your signing authority, and then deploying it onto your endpoints, whether those are WAF, firewall, server, load balance, cloud, mobile devices, so forth. That's where the AppViewX platform can integrate with all of those resources to harden your ability to manage your key structure so that you're not passing these private keys over email, placing them into centralized repositories, really exposing vulnerability of compromising your chain of trust. You also mentioned the validity period. Many browsers now are reducing the trust of certificates which exceed 1 year validity. So IT services across every industry have to address that. If they have critical IT services that aren't going to be trusted by browser instances for web applications, they're needing to reissue. Then you talk about the CDP, and can you effectively and efficiently revoke a certificate instance that's been issued either by your internal or your external certificate authority? How time consuming is that? How problematic is it? With AppViewX, it's extremely simple because you're looking at a chain of trust view on your certificate instances, and you can effectively and efficiently perform either a suspend and then reauthorize a certificate instance, or you can completely revoke them. Lastly, I just want to kind of ask to the attendee audience, first of all, has this information been relevant? And, if so, what are some of the concerns that relate to things like certificate revocation lists? If anyone has any questions, thoughts they'd like to add, we would really enjoy that feedback. So with that, we'd like to open up to any question and answer. Feel free to unmute your microphone or utilize the Q&A option within the Zoom chat session. There's also a chat option there. So we'd just like to open it up and take any interaction. Well, a question that I would like to pose to Puneet. You had mentioned, the control of the certificate revocation lists and OCP, the stapling protocol. When it comes to a major compromise, such as an intermediate or, heaven forbid, a root certificate key being compromised or exposed, have you come across a use case with an enterprise that has experienced something like that? And what were some of the impacts and how do they remediate?
So in the case, like, let's take, there are 3 use cases, which are I would say 2 use cases which are out there. One is that if you're using the software-based key management solution where you're not protecting the root CA and the issuing CA using the HSMs, in that case, the chances of compromise are really high. As I was talking about that, you can, there are utilities like jailbreak, and there are commands in the registry settings you can do, using which you can easily take the dump of the private keys, and chances get very high. Now, most of the time, what I have seen is that if people are following the best practices, it's the issuing CA which get compromised, because that's the online and kind of it's on the internet and is interacting for everything. So if that get compromised, the first step is that you go to the root CA and you kind of revoke that particular issuing CA. Okay. That in turn, what happens is that kind of make those entity certificate which was issued by that particular sub CA which got compromised kind of invalid. And you kind of basically whatever templates which were there published on that compromised issuing CA, you should publish them immediately on the second issuing CA, so the entities can still get the certificate from the second issuing CA. So that was the scenario 1. Scenario number 2, that if you're using the software-based cryptography and if you're not keeping your root C offline, it's online, and if your root C got compromised, which I just happened with one of my customers with whom I'm interacting, they had a ransomware attack and their root CA was online and they were not protecting it using the HSMs, their private keys. So in that case, they have to rebuild the whole PKI and they have to roll out the certificates throughout the endpoints. Now, here is the challenge which comes, like the endpoints which are part of the domain or the endpoints which are part of the active directories are where a GPO or you can do an auto enrollment. It's very easy to get this NAD certificate. But for the internal websites like SSL certificates and other things where you're doing the manual enrollment, then it becomes a manual nightmare basically to get the certificates to the endpoint. And that's where the platform of AppViewX can help the users. Like if they are going through any such problem, the AppViewX can automate that manual whole effort for them and can get the certificates at the endpoint much more easy as compared to doing it manually.
Right. Yeah. Yeah. Great point. You know, that manual time-consuming process of creating a new intermediate or new issuing and then deploying it out to the infrastructure can be catastrophic, I would imagine, for an enterprise if it occurs across a large distribution of their SSL, HTTPS endpoints. So great point. And, you know, when it comes to validity as well, certainly a use case that is impactful on a wide range when you have thousands or tens of thousands, and in very large enterprises, hundreds of thousands of SSL endpoints. The ability to effectively, efficiently manage them and perform lifecycle management administration through bulk provisioning, bulk distribution, and deployment certainly reduces the time that you are going to bring your services back online in the case of a catastrophic event, or just in routine management of reducing validity periods from 24 months down to 12 months so that you don't have a disruption to your customers because of browser restrictions. So I think all of those are great points.
So we have one question from Thomas, I believe, that what would be the correct criteria for selecting the type of encryption key, RSA, ECC for a PKI? So normally it's kind of like a depend on what your end entity can consume. Now, I would say that elliptic curve cryptography is more secure as compared to the RSA, but still there are a lot of legacy applications or the legacy devices within the organization which are present. So still I would say recommend that please stick to the RSA key, and normally I recommend that for the root CA go with the 4096-bit RSA key, and even for the issuing CA go with the 4096-bit key. It's not that anything on the Microsoft PKI or on the PKI which is stopping you to moving to the ECC, but it's the legacy applications and the legacy devices which are out there in the enterprises which are still not ready to consume the ECC cryptography, and that might lead to the problem. So the best way would be to still stick with the RSA 4096-bit key for at least for till the time the different devices and applications are ready to consume the ECC cryptography.
That's a good question. Thank you for that. Any other thoughts, questions from the attendee group? Love to hear from you.
Okay, I see another question. As a Microsoft PKI expert, do you think Microsoft will implement Acme version 2 in future releases of its PKI? I mean, to be very frank, I'm kind of an independent. I'm not tied to Microsoft PKI. I also work on the open source EGBCA PKI as well. But I would say that Microsoft is not going to implement the Acme version 2 in the future releases, as far as I know. If you really want to go for that, then I would say going with the open source PKI such as EGBCA would be a much more better bet than sticking with the Microsoft PKI.
Very good question there as well. I'd like to add something to that as far as features, capabilities of the AppViewX platform. So if you have an existing Microsoft PKI, and let's say, and this is where I get this question from our customers, is we're looking at deploying containerized solutions, right? Kubernetes instances, and the Kubernetes instance is going to issue the certificate requests via the Acme protocol. Well, the AppViewX can perform the um, the can be put in place as the intermediary between your legacy Microsoft PKI and your Kubernetes instances that are issuing the Acme request. The Acme request is received and processed by AppViewX. The CSR is then issued to Microsoft PKI. The certificate is obtained and then returned off to your container instance. So that solution can be incorporated so that you're not having to abandon your legacy PKI instance for, as you mentioned, an EJBCA.
Yeah, I would agree. Yep.
Any other questions, thoughts from the attendees?
Oh,
we have one more.
Yep. From a PKI architecture point of view, how do you evaluate the passive revocation of them? That is no CRL. How do you evaluate the passive revocation concept? How do you evaluate passive revocation? To be very frank, I means everybody has a different point of view on that, but I normally have never gone with a passive revocation concept. I have always stick with the high availability with the CRL, having maybe 4 or 5 web servers behind the HTTP for the CDP point. And then if the customer really has a huge CRL in the maybe 500 MB plus, then going with the OCSP. Glenn, do you want to add anything there?
Yeah, I can add something on that. So that use case, I have interacted with a customer of ours is generating certificates to be assigned to IoT devices. Now, these IoT devices, the use case there is basically the IoT device just has a lifespan in and of itself. There's really no need to issue CRL or OCSP stapling because the device itself is just out there and it's going to die. And it's going to die before the certificate expires. So really the concern there is just, do I revoke this certificate if it becomes compromised? Or let's say that the IoT device gets lost in the mail or something like that, or it wasn't received by the intended recipient, or the intended recipient, someone stole the device, something like that. So how do I control that? It's basically a short-term certificate, and the control mechanism there is, yes, you can invalidate the certificate, revoke it, but does it need to be checked with a certificate revocation list? Not necessarily, but you can perhaps break that chain of trust, and thus the certificate has just been thrown away, right? It's a commodity item.
Yeah. And I would say that's kind of an applicable if you're using the like a virtual desktop and everything as well. Those certificates is kind of like short-lived as well. That's another use case. And you don't need to have a revocation for them, because if you start adding if you have 500 employees and they're using virtual desktop and every day you're issuing them a certificate, and you add those CRL, revoke those certificates, and you add them to the CRL, your base CRL is going to grow exponentially. So as Glenn described, similarly, IoT is a one use case, and then having the virtual desktop is another use case where you don't have to worry about the CRL and everything, or stapling the CRL or OCSP. Sorry, Thomas, I think I little bit misunderstood your question there.
For validation, were we understanding the question correctly and the use case scenario without being too specific of what you're talking about?
Glenn, you're asking me or you're asking?
Oh, I was asking the attendee that posed the question.
Yeah.
Well, hopefully we'd hit that point. Additional explanation on the question. So from the point of view of PKI architecture, would you bet on an on-premise or cloud installation?
Okay. So the thing is that it's really kind of a broad topic, I would say, Thomas, because normally I can give you a call after this and can I kind of basically do a little bit of brainstorming with you, because it depend on use case. Because normally if you, what I normally suggest to my customer, I have a particular architecture in mind, which is kind of a hybrid kind of, where basically you have your root CA on premises, and you can have your issuing CA on premises and one issuing
Puneet, your audio dropped out. Are you still with us?
systems protecting all the different Can you hear me?
Yes, you broke up there for just a moment. I'm not sure if it was just mine, but maybe you could repeat a little bit of what you were summarizing.
Sure. So I don't know where I dropped off. So again, to repeat it, it's really a kind of a broad question that should I design my PKI on premises or on the cloud? I would recommend that going with a hybrid kind of an approach, where you have your root CA on premises, where you can apply the dual controls, have separation of duties and separation of roles, and then having a issuing CA on premises, scattering all the needs of the certificates within your on premises requirements, and having a second issuing CA in the cloud, which is going to cater all your needs or the requirement for the cloud, and protecting all those root CAs, issuing CAs, whether on premises or cloud, with the HSM. And Thomas, I can give you a call after this, and I can discuss this architecture if you need any help, and I can pass you the information on that in much more detail. Well, those are really good questions.
It sounds like that attendee is perhaps in the midst of a design project.
Yep, I can reach out to him and I can see how can I help him.
So I think we had scheduled for an hour, so we have significant time if there are any other thoughts anyone would like to share, questions they would like to pose. If not, I would like to make everyone aware that we're performing a series of webinars, and they do build, in essence, upon the previous topics. I can't recall, Puneet, was about 3 weeks ago we had the inaugural instance. This is the second in our series. The next webinar session will begin to go more in depth on certificate lifecycle management and describe a bit more of the AppViewX platform, how it performs certificate lifecycle management. And we would love to have everyone return and continue the discussions, the knowledge sharing. Well, it's looking like the questions have come to a close. So I'll extend one last invitation if there's any other thoughts that anyone else has. If not, I'll just go ahead and wrap up for closing comments. You'll see on the screen our contact information. You can reach AppViewX at info@appviewx.com. You can also feel free to contact me directly, which you'll see my contact information there. For Puneet Singh, you'll see his contact information. You can visit our web locations, and we look forward to continuing our webinar session and sharing information out there in the community. Anything you would like to close out with, Puneet?
I think you covered everything. And as Glenn said, feel free to reach out to us if you guys have any question on the PKI, HSMs, or certificate management, or AppViewX platform. And we are there to help you guys, and we'll continue this series as it's on every last Thursday of the month, and to do a knowledge sharing with the community.
Excellent. Well, thank you everyone for attending, and have a wonderful afternoon and rest of your week. Actually, it's still morning, but
Yeah.
thank you again.
Okay. Bye.
Bye, everyone.